So this is an example. I just want to shout out Antonio Schmitter for posting this on LinkedIn. That's how I discovered it. But he did comment that this is quite the laggy experience. So I wanted to ask Shawn what the diagnostics here, what's causing this to load slow and what could be improved.
Yeah, great. There could be a lot of reasons for this, but essentially the problem is search. I mean, it doesn't look like search, but if you're a if you're a vendor or shopping for product listing, product discovery, you've inevitably seen that search and explore are powered by the same services most of the time. So yeah, this could be a long front end delay. It could be a ton of JavaScript running. We're going to look under the hoods quickly. And we saw a minute ago that when I click a filter here, it makes a request immediately. This request is just waiting, waiting, waiting. I mean, I've got a pretty fast network, but even if I made this, I'm going to not throttle this and we'll just use my cable line and do that again. Apply a filter. This is not my computer's waiting. It's not doing anything right now. The CPU is quiet. It's all this this long backend call. So waiting for server response for 5 seconds. Every time I click a color here, it makes a new request to the server to get presumably the results of that filter. It takes 5 seconds on the server to perform that query and then returns the results. That 5 seconds is obviously the problem. And this isn't a huge amount of content. So there are ways in which, well, we can show other examples where filtering by color could be done much more performant. Should we do that?
Let's go.
So IKEA does a decent job. Imagine these were exposed. This is definitely done via Ajax or like asynchronous, an API call. So there's client side code that makes the request to get the payload for the new filter set. And let's see how long that takes, for instance. So we can see for IKEA, this search result returned in, where's our timing? 74 milliseconds. So there's a finite set of results that could be returned. The thing that this site is not doing, which IKEA probably is caching the responses to all those queries. So the browser is making a query and say, give me the results for black and red and no other filter applied. There are a lot of combinations here, of course, of filters that could be added in different permutations, different firmness, different color, etc. The problem's even less so here, though I can't read that word. Let's translate this. Okay, room type. Fair enough. Yeah. So two dimensions, we'll say here. But this can be done very performant. This can be, you want to cache the results of all these queries. So it doesn't take 5 seconds to look it all up in the database every time. That's, I suspect, is going right to a database to make this call. Taking this all the way to the extreme. Sophology, a few folks who follow Linda have probably seen this. This thing is crazy fast. I'll just zoom out a bit so we can see the couches at the same time. But their color picker, I love the size one. You can adjust. I want it to be this big or that big, and then I can change the color to, this is just ridiculously fast and really fun to play with, and a much bigger data size or sample size. So they've got, a lot of products. So it can be done in a performant way. Here, they might want to just there's nothing dynamic about each of these pages. They're all individually navigable by query parameter. Yeah, you could really just put a CDN in front of this, like Cloudflare or something, and cache the responses for all of these queries. And then it's not going back to the server at all, but use these as page navigations. So there's a few shortcuts you could take. Realistically, Alpina, this paint company, probably isn't a development agency or development shop in-house. And I imagine they're using a third party for this, and there's some optimizations that could be made.